Please hurry, take out your book, we want to start.
We didn't do question 4.
Okay, 4.1. You had to calculate the coordinates of A. I saw those of you doing it in class that you were getting it right. So they gave you the distance, they gave you a full coordinate, and they gave you half of the other coordinate. So what we're going to do is we're going to substitute this into the distance formula, substitute the coordinates, and calculate the unknown. And then that's what it looks like when you substitute. So this becomes if you square 2 root 5, it squares the 2, it becomes 4, and it squares the root 5, and it becomes 5. So it's 4 times 5, and that gives you 20. This is 2 squared, which is 4. And when you square a bracket, I can't believe I still have to say this, but I hope it's only to very few of you that most of you know this. When you square a bracket, it's the first one times itself, the first one times the second one times 2, and then the last one times itself. Then you get everything on one side, it must be equal to 0. So it's y squared, 6y. This one gives you 13. The 20 goes over, it subtracts, it's minus 7. And then when you factorize, you get 2 answers. Y and y, 7 and 1. I want to get negative 6. So it's negative 7 plus 1. So my 2 answers will be y equal to 7 and y equal to negative 1. Now in this case, since you've got a diagram, you're going to have to make the call. Will that y answer be 7 or will it be negative 1? So although it's not drawn on scale, it must be in the quadrant you are busy with. So therefore I know that the y value of A is going to be 7. So the coordinates of A, 3 and 7. (4.2) The coordinates of C. Now if I know that value is 7, which I just calculated, and this is on a straight line, it's on a vertical line, and they tell me that the length of this line is 5, then this bottom one must be 2. Do you all agree with that? Okay, so there's no calculation, you literally just say C is 3 and 2. I just want you to take a look at the way the question is asked. At A, it says determine the coordinates of A for 4 marks. So you can see that there was a calculation needed. You have to determine it. But the 4.2, although it only counts 2 as well, give the coordinates of C. That tells you that there's not much of a calculation needed to get to the answer. Okay, do you all understand? So sometimes some learners might have substituted the 5 into the distance formula and then you did the whole distance thing. And you would still get to the right answer, but you might waste some time. Okay, so that's why you need to understand the words given, and that's why we use old question papers instead of working out of the textbook. Okay, then they say show that the midpoint of AC is 3 and 4,5. So if you've got the right A and you've got the right C, then that's very easy. So it's going to be x plus x divided by 2 and y plus y divided by 2. And I would suggest, while you guys are doing homework especially, write down the formula before you start doing the sum, because that helps you to get to know the formula. Because For the distance, there's a minus in between. For midpoint, there's a plus in between. And I told you, if you write down the wrong formula, if you've used the wrong formula, you put a minus there instead of a plus, we don't mark any further. That's where we stop. Okay. So it's going to be 3 plus 3 divided by 2, and then 7 plus 2 divided by 2. And that gives 3 and 4,5. Now, if it's a question like this where they are giving you the answer, you have to especially show the calculations. Okay. You have to show the substitution and everything, because that's where you're getting the marks. You're not getting the marks for the answer because they gave you the answer. Then they say determine the coordinates of D so that ABCD is a parallelogram. So they are saying wherever you put D, once you put it there, it must be a parallelogram. So I'm just going to repeat what I said yesterday. They say it's parallelogram ABCD. Therefore, I know it's ABC and D must be somewhere there. The reason that's important is to determine my diagonals. Right. So we said in a parallelogram, the main property in grade 11 is that the diagonals bisect each other, and that means that their midpoints are at the same place. So what we're going to do is we're going to take two of the coordinates that we know, A and C, that create a diagonal, and calculate the midpoint. And once we have that midpoint, we're going to let it be the answer of the midpoint sum between B and D, and that's how we will calculate the coordinates of D. Does that make sense to you? All of you? Okay. So the midpoint of AC is going to be 3 plus 3 over 2, and you know they already gave it to you, ne? So you actually didn't even have to calculate it, but that's why they gave you the answer at 4.3. Because if you weren't, maybe you got the wrong A and C coordinate, then you've got that right midpoint. Remember, if they tell you this is the midpoint, prove that this is the midpoint, then that is the midpoint. Okay, so I get 3 and 4,5. Now, I'm going to do it firstly mathematically, and then I'm going to show you a cheat. Okay. So with the other one, I'm going to take the midpoint of BD. It's 1 plus x over 2 must be equal to 3, and 3 plus y over 2 must be equal to 4,5. So that 2 goes over, it multiplies. So it's 1 plus x equal to 6, and then x is equal to 5. And this one, the 2 goes over, then it's 3 plus y equal to 9, then y is equal to 6. So the coordinate of D is 5 and 6. Would you mind closing the door for us? Now let me show you the shortcut. And you can always use the shortcut, you don't lose marks for it. Unless they say, like, you have to prove that that is the midpoint, so they give you the answer, then you can't use the cheat, because then you have to do the sum to show how you got to it. But if you are calculating this coordinate, that midpoint is 3 and 4,5. Do you agree with me? All right. Let's look at B's x value. How much was added to 1 to become 3? So then I will add 2 to 3. This one will be 5. Okay? Which was right according to our calculation. What happened to 3 to become 4,1? 4,5. Plus 1.5. What is 4,5 plus 1.5? And that was the answer that we got. So if you have the midpoint and you have to calculate the other point, you can count it. So what happens from the point 1 to the midpoint, we'll just repeat to the midpoint to the next point. You will see some of the questions that we're going to do. It counts 4 marks. Then you use the cheat, you get all 4 marks. Okay. only time you can't use it is when they tell you, prove that the coordinates of D is 5 and 6. Then obviously you can't cheat because I wouldn't know how you got to the answer. I'm giving you the answer. Okay. You all understand? Right, we left out 4.5 and then we move on to question 3 of 2018. Three point one, the first one was very easy. It's the gradient of BC. So you see, when I want to show a gradient, I use a small letter M. Midpoint is capital letter M, and then I write the line points so that I know which line I'm working with. Because sometimes you're going to calculate many gradients or midpoints or lengths, and then you don't know which one was which. So rather get into the habit of writing it like this. So the gradient formula is y minus y over x minus x. It is 5 minus negative 3 divided by 6 minus 0. Remember, if you start with b's coordinate y, you must start with b's coordinate x. Do you understand? So these two must go together and those two must go together in a coordinate. Right, and then you do the calculation and your answer will be 8 over 6, which is 4 over 3. Do you agree with that? Then they said at 3.2, determine the equation of AD. Now I'm going to say this again, we spoke about it yesterday. At AD, I've only got one full coordinate. Now listen to me. You need two full coordinates to find the equation of a straight line. Okay. Two full coordinates. You don't have it here. You've got one full, one half, and one where you have nothing. If that's the case, you need to look for something to steal. Now when we say we steal it, you must either look for a perpendicular line, or for a parallel line, or for an angle. Those are the three ways that we can get a gradient other than using the coordinates. If you have a perpendicular line, the gradients will be swapped around with a negative. If you have a parallel line, the gradient will be exactly the same. If you have an angle, inclination angle, you know that the tan of the angle is the gradient. Those three ways. Okay. So, I would write this for myself somewhere. 4 total ways finding a gradient. The formula, parallel lines, perpendicular lines, or an inclination angle. Okay, since we don't have two coordinates, we need to go and look for one of the other methods. Now I can see the parallel lines. And also, like we did with Euclidean geometry, you can use color pens or highlighters to just keep your eye on what they've given you. Those two are parallel. Their gradients are the same. So I can steal BC's gradient. So the way we would write it, if I do it very formally, I would say BC is parallel to AD. That was given, so there's no reason for that. So thus, the gradient of BC is equal to the gradient of AD. So I'm explaining why I'm doing what I'm doing in mathematical language, which is not that hard, So we say, thus, the gradient of AD is equal to 4 over 3. And I can put it in the equation. Y is equal to 4 over 3 x plus c. Now once you have either the gradient or the y-intercept, which is c, all you need is just one other coordinate that you can substitute into x and y. Now if you look at that line A and D, that coordinate must be on AD. Né? I have a coordinate for A. So I can take the A, which is negative 2 and 2, and substitute it into x and y. So y is 2, x is negative 2, plus c. And then you find c to be 14 over 3. So your equation is y equal to 4 over 3x plus 14 over 3. Do you all understand that? This is an important question. Then at 3.3 they asked you to calculate the value of t. Now I will show this again in a minute, just look on the board. Now if you've got the equation of a straight line, you can calculate any value of a coordinate where you have the other value of. So I know that this y is 0 at n. So all I have to do is substitute the y with 0, and then I have only one variable and I can calculate it. Does that make sense? Okay? So I take n, which is t and 0. So 0 goes into the place of y because it lies on the line AD. I don't have the x value, that's what I want to calculate. And it's 14 over 3. Then I get x to be, I think it's 7 over 2. What is it, 7 over 2? Negative 7 over 2. And that is the value of t. Then 3.4, calculate the length of AN. So A, the coordinate I have, is negative 2 and 2. And N, the coordinate I have, is negative 7 over 2 and 0. So AN will be equal to the square root. And you see now I'm using the square root 1 again because I want the distance. If they give me the distance, I'd rather use this square formula. Then all you do is you type that in your calculator and you get an answer of 5 over 2. Am I correct? And that's why it only counts 2 marks. Because it's a formula that you substitute in and just typing it on your calculator to get the answer. .5, very important. You have to find the coordinates of D, this one right here. But you don't have anything there. They are telling you that DC is defined by this equation. So obviously you need that for something. Otherwise they wouldn't give it to you here. Now we spoke about it briefly yesterday. If you have the equation of 2 lines, the equations of 2 lines, you can let them be equal to each other to determine the point of intersection. You did that in grade 10, am I right? Some say yes, some say no. Okay. it's the same as simultaneous equations. We are also going to do a lot of this when we start doing functions, right, or the graphs. So whenever you want to know, make a note, where two graphs cut each other, where they intersect, then you let the equations be equal to each other. So you know, we spoke about standard form of an equation. This is also why it's very important. Because if your equation is in standard form, then your y will be a loaf. Now, if I tell you that Leakwe is naughty, and I tell you that Katleo is naughty, we can say that they are the same. Do you agree with me? Okay. So if this equation is equal to y and this equation is equal to y, we can let them be equal to each other because they're equal to the same thing. So I'm going to say 4 over 3x plus 14 over 3 is equal to 3 over 8x minus 3. And then you need to know how to work with fractions. Different ways that you can do it. You can try to find the LCM of the denominators, which will be 24. Then you multiply each one with 24. Now the problem is you can't use a calculator here because of the x's. You must know how to do it. So here the 3 cancels out the 24, it becomes 8, so it's 4 times 8, and 4 times 8 is 32x. Here the 3 cancels that one out, it's 8, it's 14 times 8, so 10 times 8 is 80, and 4 times 8 is 32, so it's 112. The 8 and the 24 cancel, so it's 3 times 3, which is 9x. And then just 3 times 24, 3 times 20 is 60, and 3 times 4 is 12, so it's minus 72. Then you get everything on the same side. Let me just use this calculator here. 112 minus 72. That gives me 40. Did I calculate right now? Over 3 times 24 is 32. 14 over 3 times 24, 112. 3 over 8 times 24 is 9. No man, you must add these two. Okay, plus 112. That gives me 184 on this side. And 32 minus 9, that gives me 23x on this side. And then x is equals to 8. Now all you have now is the x value of d, which is 8. Now you're going to have to substitute the 8 into either of these equations. I would rather choose the DC equation because of the denominator 8. Then I would say 3 over 8 times 8 minus 3. That gives me 3 minus 3, and it's 0. No, what am I doing now? Right, let me just calculate this. It's negative 8, excuse. And then you get negative 6 here. That's why it's not working out. Do you understand the method I used here? Everyone? Will you remember that? Point of intersection, let the two lines be equal. Okay, now at 3.6, we have to prove that this is a parallelogram. There are multiple ways that we can do it because we've got all 4 coordinates of the vertices. So I said yesterday, because these 2 lines are parallel, first option, you calculate the length and you calculate the length. If they are equal to each other, you've proven a parallelogram because one pair of opposite sides will be parallel and equal. Second method, because these are parallel, you can calculate the gradient of AB and calculate the gradient of CD. If these 2 gradients are equal to each other, you've proven a parallelogram because 2 pairs of opposite sides parallel. Obviously, you can take it very far and go and calculate this length and then calculate this length, and then you've proven two pairs of opposite sides equal. But can you see it only counts 3 marks? So it's not worth all that effort. You need to know what makes it a parallelogram. So it's those first 2 that I said, and then the third way, which I hope you all know now. What's the third way? The diagonals bisect. So I can calculate the midpoint of BD and I can calculate the midpoint of AC, and if the 2 of them are the same, then this is a parallelogram. Which one do you want me to do? Bisecting. So the midpoint of AC is minus 2 plus 0 divided by 2, and 2 plus negative 3 over 2. This gives me negative 1, and that is negative a half. Then I check on my sketch, does it make sense that m can be negative 1 and negative a half? Yes. Then I go and calculate the midpoint of BD. 6 plus negative 8 over 2, and 5 plus negative 6 over 2. That's negative 2 over 2, which is negative 1. That's negative 1 over 2, which is negative a half. But now, very important, now you have to answer the question. Okay, so I've done the maths now. Now I answer the question. So you say thus, A, B, C, D is parallelogram. That's how we abbreviate parallelogram. Why can we say that? Diagonals bisect. Done. And now because you chose to do this one at 3.6, at 3.7 you can just say m is equal to negative 1 and negative a half. Are you guys getting the hang of it? Are you sure? Okay, we're moving on to 2017, question 3. You're going to do for me question 3 and 2017 question 4. Okay, so you're doing 2017 for me for Thursday. But let's quickly work through this one at question 3. They say that A, which is negative 2 and 5, B, C, and D are vertices of a quadrilateral ABCD. What do you suspect if you look at this visually? So we can't go on this, but what does it look like, this quadrilateral? A kite. Do you see that? Do you remember what makes a kite a kite? Firstly, the new one, the diagonals are perpendicular. Check. But we cannot just go on that. Do you know what else makes a kite different from the other quadrilaterals? What? Two adjacent sides equal. Now do you see they gave you the length of AB? So if there was some way that we can find the length of BC and it's 15, then we know this is a kite. Okay, but let's see what they're giving us here as well. Such that diagonal AC is perpendicular to diagonal BD at T. What does the diagonal also tell us? The gradients are swapped around with a negative, if I were to have the gradients. And then they tell us that the equation of BTD, I'm going to highlight it. This one. Do you like the equation as it is there? Can I someone change it already? So it is y equal to negative a half plus 9. Do you know how I did that? I took the x over to become, I'm forgetting to write the x. For it to become negative, and then I divide everything by 2. So this line is y equal to negative a half x plus 9. Without us doing or answering any of the questions, who can tell me something that they can get from this equation? The gradient of what? The gradient of BTD is negative a half. How can I use that? Come, try. I just said it. Yes, Moto. That's right. The gradient of ATC, let me just call it AC, is that okay? You know which line I'm referring to. The gradient of AC is going to be what? No. The product of these two must be negative 1. So what is this gradient going to be? Swapped around with a negative. So what will negative a half look like? 2. Do you all understand that? Sure. Okay. So that I get from that gradient and the fact that the lines are perpendicular. So you must be wakker for these type of things, ne? They are giving you clues and you mustn't miss the clues. Alright, and then they tell us that that AB is 15 units. Right, look at the first question. Determine the gradient of line AC. So we just did it, no? But you're going to have to write that. You get the equation in standard form, you swap it around, you give it a negative, and you tell me why did you do that? Because the gradient of BD is times the gradient of AC is equal to negative 1 because the lines are perpendicular. Okay. Right, 3.2. Determine the equation of AC in the form y equal to mx plus c. So you've got m. Do you have a coordinate to find the value of c on AC? Yes, we've got the coordinate of A. Next up, if the equation is y equal to 2x plus minus 1, calculate the coordinates of t. T is a point of intersection. How do we calculate the coordinates of a point of intersection? Moana, what are you saying? You let the two equations be equal to each other. Remember, you've got the equation of BTD. You have the equation of AC. You let them be equal to each other. Okay. And then they say if ABCD is a kite. So it is a kite. Now you can use all the properties of a kite. Calculate the coordinates of C. So now I know that this one and this one is equal. This side and this side is equal. I know that that is the midpoint. Ne? Because do you see at C, I'm going to have to calculate two coordinates. Do you see that? Can I do that with distance? Can I do that with gradient? Can I do that with midpoint? Yes, so I have the coordinates of t that I calculated at 3.3, and you can use the long method or you can use the short method where you count it up. Calculate the length of BT. You've got all the information, you've got the coordinates, you can calculate it, and then you see that 3.4.2 it counts 4 marks. So you're going to have to work with that one a bit. Write down the lengths of the radius of a circle passing through points B, T, and C. So a radius, let's see if you guys get that right. You've got some Euclidean coming through there, Euclidean. All right, and then also the next one, question 4 on the next page as well. Go.